This is Unit G, Concepts 1 through 7, finding vertical and slant asymptotes that may have a hole. So this is our equation, x to the third plus 3x squared minus 8x over x squared minus x minus 2. So we have to determine whether it's a horizontal or a slant asymptote. So to find out if it's a horizontal or a slant asymptote, we can look at these boxes. So if it's a horizontal, the degree on bottom has to be bigger, or it has to be the same degree. For it to be a slant asymptote, the degree on top has to be one bigger than the bottom. So in our equation, the top degree is bigger, so it's going to be a slant asymptote. So we can cross off the horizontal asymptote. To find our slant asymptote, we are supposed to do long division. So we have to perform long division. So x squared minus x minus 2 is going to be the one we have to divide into x to the third plus 3x squared minus 8x. So what we get out of that once we perform long division is x plus 5. So once we get that, our equation has to be in y equals mx plus b. So y equals x plus 5. Once we have that, we can find our vertical asymptotes. To find our vertical asymptotes, we are going to have to factor the top and the bottom and set the denominator equal to 0. So once we factor, we can factor the top with an x, and then once we factor the inside, it's going to be x plus 4, x minus 2, and the bottom factors out to x minus 2, x plus 1. And then x minus 2 and x minus 2 cancel, which is going to lead us to have a hole. So for our vertical asymptotes, we have to have the simplified equation, and then we have to set the denominator equal to 0. Once we do that, x equals negative 1. Once x equals negative 1, our limit, we can put our limit notation. But until we graph our asymptotes, we can know whether it's going to be negative infinity or infinity. So once we have that, we can go to our holes, which is what we canceled out, which is 2. And then with our simplified equation, we have to plug in our hole, which is 2. Once we plug that in, we end up getting 12 over 3, which will simplify to 4. So our point that's going to have a hole is 2, 4. So we can go down and do our denominator. Our domain. We have to technically set the numerator equal to 0 in our simplified equation, which is x parentheses x plus 4 equals 0, which will give us negative 4. And since there's an x outside, x is going to equal to 0, so it's going to be 0, 0. And for our y-intercepts, we have to set our x equal to 0 on our simplified equation. So once it's simplified, it's going to be 0 over 1, which is going to be 0, 0. So we can graph these points now on our graph. This is going to be our hole. Which is 2 and 4. So we leave our hole as an open circle. And then to find our limit notation for vertical asymptotes, we have to plug in our simplified equation to our graphing calculator. So we are going to have to plug in x plus 4 over x plus 1. So then once we hit graph, you can see our vertical asymptotes, which is going to be -1 since we got that for our equation. So then we sketch that out. So as x is going negative infinity, which is to our left, you can see that it's going up, which is going to be infinity, and as x is going to infinity, which is to our right, you can see how it's going down, which is negative infinity. Since we only have 3 points in our graph, we're supposed to add 3 on each side. So we can add -2, -3, and -5. So, and then to our right, we can add 1 since we already have 2 points, which was our whole, and our y-intercept and x-intercept since it was the same one. So once we plug that in, we get 4, 1.5, and -1.25. And then for our 1, it's going to be 2.5. So once we plug those in, we can sketch out our graph, and then that's how you find your slant asymptotes, your vertical asymptotes, how to graph our whole and our graphs and do the whole equation. Thanks for watching.